Hello everyone. In this video, I will be giving a brief introduction about the topic gravitation. In this video, I will be talking about the Kepler's laws and the Newton's universal law of gravitation. Okay, so we can see an introduction about gravitation. Every object in the universe attracts every other object with a force which is called the force of gravitation. That is, in this universe, every object that exists exerts a force on the other objects in the universe. And the name of this force is known as gravitation. And the force of gravity depends on the mass of the object. That is, mass is the total amount of matter contained in an object. Highly massive objects have got a higher gravitational force. That is why Sun has got a really big gravitational force and the planets revolve around the Sun. It is gravity that holds the universe together. So we can say that gravity is the glue that holds the universe together. The planets move around the Sun due to the force of gravity. Johannes Kepler gave three laws to explain the planetary motion. So we can see what these three laws are. First, Kepler's laws of planetary motion. First law is known as the law of orbits. It states that each planet revolves around the Sun in an elliptical orbit with the Sun at one of the foci of the ellipse. An ellipse is shown in this figure and Sun is placed at one of the foci. So the planet, the path of revolution of the planet around the Sun is given by the elliptical path. Here 2a is the major axis of the elliptical path and 2b is the minor axis of the elliptical path. Now, second law, that is law of variance. It states that the speed of the planet varies in such a way that the radius vector drawn from the Sun to the planet sweeps out equal areas in equal times. It is shown in this figure. Here we can see the initial position vector of the planet is a p. After time, it is p dash, and the area which it sweeps in this time is delta A. Area delta A remains the same for equal amounts of time. That is what the second law, Kepler's law, states. Now we can see the final law of Kepler given by Kepler, and it is called the law of periods. It states that the square of the time period of revolution is proportional to the cube of the semi-major axis of the elliptical orbit. Now we can see the Newton's law of gravitation. According to Newton's law of gravitation, every body in the universe attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. And the force of gravity acts in the direction which is the, in this figure, the direction of the vector r. So the formula of force can be written as magnitude of force is equal to G into m1 into m2 by r square, where G is known as the universal gravitational constant, and the value of G was found out by Henry Cavendish by doing some experiments. Here M1 and M2 are the masses of the two bodies, and R is the distance between the two masses. Now we can see the principle of superposition of gravitation. It states that the resultant gravitational force acting on a particle due to a number of point masses is equal to the vector sum of the forces exerted by the individual masses on the given particle. We know that in real world, many bodies interact with each other. So, the resultant force acting on a body is given by the vector sum of all the gravitational forces acting on this body. Its formula is given by F, which is the resultant force, is equal to sigma I is equal to 1 to n F0 I, where F is the force which bodies of masses m1, m2, m3, etc. mn exerts on the body. This is known as the principle of superposition of gravitation. So this is the end of this video. In this video, I have just given a brief introduction about gravitation and the Kepler's planetary laws of planetary motion and the Newton's universal law of gravity. If you have got any doubt in any of the concepts discussed in this video, please comment in the section below this video. Thank you.